regions in complex plane. So in this discussion, we are going to study geometrical and topological properties of different regions in complex plane. So in other words, if we have a region in a complex plane and if we have a point, then the question is how close the point P is with that region, or if the point P lies inside the region, outside the region, or at the boundary of that region. Now, intuitively, it's a very simple idea, but we want to write it down in a mathematically precise language. So the main concept that we are going to use in our discussion is a very simple concept of a circle. Now, what is a circle? A circle is a set of points in plane whose distance from a fixed point z0 is constant c. So in other words, if this is the point z0 and this is the distance c, then circle is basically a set of all these points. Now these are all the points whose distance from z0 is equal to c. So in plane, there is no other point whose distance from z0 is equal to c apart from the points on this circle. Now, if we want to calculate, or if we want to describe different geometrical properties of the region, then we are going to need notion of distance. In other words, given two complex numbers in the complex plane, what is the distance between them? So in other words, we should be able to use our previous knowledge to see that if we are given a complex number z1 and the second complex number z2, then the distance between them is basically the modulus of this complex number z1 minus z2. Now, let's use this distance to describe a circle in complex plane. So, of course, we know that a circle is a set of all points whose distance from a fixed point z0 is constant. So, in this case, the constant is epsilon. So, mathematically speaking, it becomes the following expression. So, it is basically, this equation is saying that find all complex numbers z such that when we calculate the distance of z from z0, then this distance is equal to epsilon. And all such z will form a circle in complex plane. And the center of this circle is z0 and the radius is epsilon. Now, continuing in this direction, we can define a closed disk. Now remember, once again, what is a circle? So circle with center z0 and radius epsilon, a set of all points whose distance from z0 is equal to epsilon. Now, if I change this equality with this inequality, so in other words, now the question is find all complex number z whose distance from epsilon is whose distance from z0 is either equal to epsilon or less than. So in other words, a set of all the points on the circle and set of points which are inside the circle. Okay, so if I go outside the circle, let's say this point, now the distance of z0 from this point, let's call it h, is definitely greater than epsilon. But if I consider any point inside this circle, then this distance is definitely less than epsilon. So in other words, a closed disk is set of all points which are on the circle and inside the circle. Okay. Similarly, on the same lines, we can define an open disk. So an open disk is set of all points whose distance from z0 is strictly less than epsilon. Now observe that there is no equality in this case. So in other words, the points on the circle of radius epsilon and center z0 will not be included in this case, but every other point inside this circle will be included. So this is our open disk. As we can observe that the boundary is not included, so that's why we are calling it open disk. Now continuing in this direction, now let's define neighborhood of a point z0. Okay, now as we can see from the name that it is something about the closeness or the neighborhoodness of a point. Okay, so, and we will see that we are going to use this idea to explore how close a point is with a given region or a set in the plane. Okay, so what is epsilon neighborhood of a point z0? So an epsilon neighborhood of a point z0 is just an open disk of radius epsilon. Of course, in this case, it includes all complex numbers whose distance from z0 is strictly less than epsilon, and of course the boundary is not included. So normally we'll just talk about neighborhood of a complex number when the value of epsilon is irrelevant. Our next definition is about deleted neighborhood or punctured open disk. Okay, so as we can observe from the name that it is a disk, but it is punctured. Okay, so in other words, if I have an open disk and if I puncture it, in other words, if I exclude this point z0 from this disk, then it becomes punctured. Okay, so mathematically speaking, it is set of all points z whose distance from z0 is strictly less than epsilon, and the distance is not going to be equal to 0, and it is strictly greater than 0. Of course, in this open disk, there is only one point whose distance from z0 is equal to 0, and that point is z0. And if we exclude that point, then we get this punctured disk. Our next definition, where we are going to use our previous discussion of neighborhoods and circles and open disks to define when a point is interior to a set S. Okay, so geometrically, if I just sketch this set S in the following form, and if I take the following point, then we can easily see that it is not interior to S. And if I take another point like this, then intuitively we can easily observe that it is inside this set S. Now we want to define this phenomena mathematically in a precise language. Now what is the difference between these 2 points? So the difference between these 2 points is, let's call this point P1 and let's call this point P2. If I take this point P1, then I can easily find an open disk centered at P1 which is contained in this set S. And for this point P2, there exists this following disk with center P2, and here this epsilon, which is the radius of this disk, is some distance. Okay, so but the point is there exists one such open disk such that this open disk is not contained in S or even does not intersect S. So this point P with this property is called the interior point. So in other words, if we are given a point Z0, then this is interior point of the set S whenever there is a neighborhood of Z0 contained in S. Now we can also take the point to be as close to the boundary of S as possible, but still we will be able to find a very small disk such that that open disk with center that point is contained in the set S, and we can say that this point is interior point of S. But if I take this point, still the disk is very small, but still we are able to find a disk which is not contained in S. So this point is not interior. So we have mathematically defined when a point is interior to a given region or a set and when it is not interior. So if a point is not interior, then there is another kind of points which we call them exterior points. So in other words, if we are given the set S, then a point is called exterior point if there exists a neighborhood of Z0 not contained in S. So in other words, if this is the point P, then it has the following neighborhood, and this neighborhood is not contained in S. So we call this point to be exterior point. Now between these two points, the interior points and the exterior points, there is another kind of points which does not fall in any of these two criteria. So these kind of points are the boundary points. Okay, so on the boundary, so what are the properties of the points which are at the boundary of any set S? So if I take any neighborhood of this point, then it will neither be outside S nor will be contained inside S. Okay, so we can say that these are very special points, or these are different than interior and exterior points, and we call them a boundary point. So precisely, a point Z0 is a boundary point of a set S if it is neither an interior nor an exterior point. So in other words, if I take a neighborhood of a point which is at the boundary, then every neighborhood of this point will contain some points of S and some points which are outside S. So it will never happen that if a point is a boundary point, so there will no neighborhood of that point which is entirely contained in S or entirely contained outside S. Okay, so every neighborhood will contain some points of S and some points outside S. And set of all boundary points of a set S is called the boundary of S. Okay, so for example, consider a set S which is defined as this closed disk. Now, why this is closed disk? Because I can write it down in the following form: Z minus 0 modulus less than or equal to 1. So basically it becomes a closed disk with center origin and radius 1. So now in this case we get the following disk. Now what are the boundary points in this case? Of course, this point is not boundary point because we can find an open disk, or we can find a neighborhood of this point which is outside S. So it becomes an exterior point. And similarly, if we take the following point, then it becomes interior point because there exists a neighborhood which is contained inside this set S. So what are the boundary points? So the boundary points are this point. So every open disk with center this point, or every neighborhood of this point, contains some points of S and some points from outside S. So basically, set of these points which are exactly the circle of radius 1 is basically the boundary of this set S. Okay, so what is boundary of S? So boundary of S is basically circle of radius 1. Similarly, if I consider another set S2 defined by this inequality. So what is this set S2? So now this is an open disk. In other words, set of all points whose distance from the origin is strictly less than 1. So in this case it becomes something like this. Now in this case the boundary is not included. But what is the boundary of this set S2? So once again, this point is not at the boundary. Similarly, this point is not at the boundary, but the boundary is once again the circle of radius 1. Okay, so in this case, the boundary is the same circle of radius 1. Now in this discussion, we started with defining circles in complex plane, and then we defined what are open disks, what are closed disks, and we defined very important notion of neighborhood of a point. And using that, we defined what is an interior point, what is an exterior point, what is boundary point, and what is boundary of a set. So we'll continue our discussion where we explore further geometrical and topological properties of regions in complex plane.